computer. He's kind of an interesting story there. My brother was your classic, you know, not doing very hot in high school and all that stuff, and he hated high school. He definitely would have been a good candidate for online high school, definitely.
Classic brother.
Classic brother, classic. But he's a really good example of finding something that fits. Math was something that started making sense to him, and he's going into video game design. And it's just interesting because he tells me he uses like geometry, trigonometry, some algebra properties all the time, and you wouldn't even think it. It's crazy. It really is. And like he uses trigonometry and equations to try and figure out the different angle the sun should hit in his video game to have the proper lighting. Right. But you would probably get paid more money. Yeah, you're right, CC. Yeah. But you probably get paid more money if you're the one writing it, right? Creating the game.
Well, yeah, because you keep on getting money for everyone that buys the game. If you test the game, you only get paid for testing the game. So you kind of get less money for testing a game than making a game.
Paused it.
I agree with you 100%. That's cool, Lizzie. Go play. Come on. Oh my gosh, my kids. Yeah, here's the thing. Like he's not like what you would call your my brother actually has severe OCD. It's very interesting. So he kind of hyper focuses in that area, and it just made him get obsessed with it and really love it. It's pretty cool. You can even take a class on how to design apps. It's pretty neat. Pretty cool. But on the screen are some different math things that you need for certain careers. Right now, he's making kind of your classic. He's a fan of the classic platforming games. Like he likes the Mario, the Donkey Kong, like the scrolling platformer, and he's trying just to have the super updated graphics. And it's crazy how much math code it takes to make realistic water, to make proper lighting. There's so many things that go into it that you just don't think.
What about canine officers or police officers?
Oh, this is just a few. This hands down is just a few. Is that something you want to be when you're
I want to be a canine officer.
Oh, yeah. Too cool. Hands down, I bet you that would take some stuff with statistics and all that.
Because you need to understand like grams and stuff.
Yes. Oh, yeah.
Well,
Oh,
that's
really?
cool.
Oh, I'm so sorry.
Hmm.
Ben, we actually teach a coding class here. It's pretty cool. Oh my gosh. We do. Yeah. There's a coding class here. Jim teaches it. Yeah. It's pretty neat. Um, talk to your advisor or counselor about it. Oh, your kitty loves you, Aiden. And they'll tell you when you can take it. Yeah, talk to them because it's pretty cool. Sorry about that. Do I know Timothy Jones? No, I don't think so. Was that a person who went here? Was that your grandfather? Oh, okay. Oh, that's your grandfather? Oh.
Can I say hi?
Oh, man.
I just want to say hi. Hey, Mom.
Hi, buddy. Go play. Okay, come on.
Foot. Foot.
Oh, man. That's Logan. Thanks for remembering his name there, unless I said it. I could have said it. I'm not sure. Not as with it as usual. Okay. Yeah. My Logan. He will be back to interrupt us. Oh, well, thank you. He will be back. He can't help it. All right. It is week 8. Week 8. This is what is due this week. There's 4 assignments. You guys who are new to the class, I'm going to make sure that you all have Math Excel accounts. And yeah, that might be the only thing, but you could definitely work on the math mindset assignment. And then you have an assignment about properties, only 8 questions, super quick, order of operations, and evaluating expressions. Today, we're going to evaluate expressions using the order of operations. We're going to learn about evaluating algebraic expressions and learn about the properties in algebra. Okay, I'm going to pause for a second and tell my daughter to go back in the other room. I want you guys to think about, what is the order of operations? What does evaluate mean? Okay, my goodness, those children. Her name is, yeah, she would love that. Let me tell you. So what do you guys think? What is the order of operations? Does anybody remember that?
Parentheses, exponents, multiplication, divide, add, and subtract.
Beautiful. Very good. So we would say PEMDAS. Yeah, very good. Except I like to write it like this. It looks a little weird, I know, but
It's multiplication and division and addition and subtraction.
Yep, you're right. Because when you have just those left, you go left to right. That's what I always do that. Good. So parentheses, exponent. Yes, they do. The G stands for grouping. That's what they'll say, but I prefer PEMDAS. That's what I do. Yeah. Yeah, I know. That doesn't work. Because then you can't do please excuse my dear Aunt Sally, right? It's perfect. Yeah. Please excuse my dear Aunt Sally. That's another way to remember it. So, question, guys, right here, see this thing? It says evaluate n plus 7 for n equals 4. What does that mean? What would we do?
Find what n is. Like, so you would do 4 plus 7.
Yeah, exactly. And we wouldn't find what n is because they're telling us n is, but we would take that 4 and put it in there and then get the numerical answer. That's called evaluating something. When you take what they tell you the variable is, you plug it in, and then you get the numerical answer. It's different from solving. Whenever you solve something, solving would look like this. So that one has an equal sign. We would solve the equation to figure out what n equals. And we can't do that when you have just n plus 7 because it's not equal to anything. So when they tell you to evaluate, you plug it in and then get the numerical answer. Okay, good stuff. All right, so for this one, we're going to kind of do that same process. We're going to replace everywhere there's an x, we're going to replace it with 16. Very good. Oops. Oh my gosh, I always do that. I switch it, and I don't mean to. There we go. So we're going to replace that x with 16. I love that my children are blowing into like
The
a whistle.
recorder?
Oh my god. I think they're trying to drive me nuts today, I tell ya. Whoever idea it was to not have school for us. Yeah, I tell ya. That's right. No, I'm just kidding. That's why I work with middle schoolers and up. Younger kids, no way. My own drive me nuts. So, all right. So, when I'm gonna evaluate here, where would I start? Yeah, I'm gonna start in the parentheses. So 16 plus 2, that gives me 18. Very good. And now we're gonna take half times 18, or half of 18, which is the same as 18 divided by 2, which is 9. Very good, you guys. Good. Now, let's say you're like me and you hate calculating things. Let's just say, you know, the whole calculating stuff thing, it's just not working for you. There is a really cool website. I'm going to put it in chat. Oops. Oh my gosh. Stop.
Hi, Mom.
Ay, ay, ay. Right? That kid, I tell you. Okay, I'm gonna show you the website. So it's Desmos. I put it in chat there. So let's say, you know, we don't feel like evaluating all that stuff. So we're just gonna type it in exactly how it was. There's a fraction button already there. We can type in 1 over 2. We'll still use parentheses. Oh, I forgot what it was. It was 16. We're going to plug it in. Whenever I plug something in, I always plug it in with kind of an extra set of parentheses around it, just because it helps in certain situations. Plus 2. Check it out. It looks so nice the way it's written, and it tells you the answer right there. So this is a great website that we will be using. My daughter's trying to get my son to go in the toilet. I don't know what's happening. Yeah, don't know what's happening there. Of course, they save this until I'm trying to teach, right? Right? Yeah, who knew? Okay, take a look at this one. This one looks kind of beastly, right? So everywhere there's an X, what are we going to replace it with?
-2.
-2, yeah. So let's have you guys try and type it in Desmos. I'm going to do some extreme parenting here. I will be right back.
Parenting to extreme.
Those kids, I tell you. All right, let's see where we're at. So what we're doing is everywhere that there's an x, we're going to replace it with a -2. Okay? So -2 plus 5 minus 3 times -2. Now, if I followed the order of operations, I'm going to do what's inside those parentheses first. Okay? So -2 plus 5, what is that? What's -2 plus 5? -3, right. And this is where it helps to keep those parentheses. Oh, it wouldn't be -3, it would be +3. +3, because that's like saying, yeah, that's like saying, yeah, just 1 second, definitely. So we have 3 squared minus, now here's another set of parentheses, 3 times -2. What's 3 times -2? -6. And if I put that -6 next to this negative, there's a negative thing going on here. I'm going to end up with a plus. And then plus, this is almost like a thing of set of parentheses here. I can still take care of that. What is the square root of 9? Oh no! I hate it when that happens. Oh, 3. Yes, very good. So now we're left with 3 squared plus 6 plus 3. Okay, what's 3 squared? 9. Yeah, 9 plus 6 plus 3. So 9 plus 6 is 15 plus 3. Oh no! Is 18. We should get 18. Did you guys get different answers in Desmos?
I got 18.
You got 18? Okay. Let's put it in Desmos and see what Desmos says. So in Desmos, oh good, good stuff, you guys. Well, that's okay. That's the tricky part about this, is it's all about how you enter stuff in. And sometimes using that extra set of parentheses really helps. So that -2, okay, that -2 was an x, and when I plug it in, I'm going to use an extra set of parentheses around it. And negative in Desmos is the minus sign. So -2 plus 5. And now I'm going to raise that to the second power. You got to be careful to type it in exactly how it looks. -2 plus the square root of 9. Enter. 18. So look at how I have it written in Desmos and check it against what you guys put in. You guys who didn't get the same answer. On your... Yes, you can. Yeah, that's a good point. You don't have to use the mouse and click it. You can type the numbers in. Thank you. Yeah. Yep. See, and that is so easy to do. And I'm glad that you're saying that because, gosh, that's such a common thing. So easy, one wrong thing, and you get. That's why it's really helpful to have something like this where you can go back and see what you typed in. Good. I'm so glad you're willing to say that. Thank you. Let's do another one. This one looks kind of gross. Blah. Look at it. Ew. Gross one. Okay. So whenever there's an X, what am I going to replace X with?
Then 2.
2. Yeah. And what am I going to replace Y with?
3.
3. And this is where it helps to put in that set of parentheses when you're doing that. Because if I didn't do that, look what this looks like. Look, I've got my 5, and now here's X. I'm going to put 2 in. It looks like I'm just writing 52. That's confusing. That's not what they want you to do. They want you to take 5 and multiply by that X. Whenever it's right next to a variable, you have to multiply. Aiden, perfect. I love that. And now we're going 2 times 3. Close that parentheses and we raise it to the 3rd power. Here's our 2 to the 3rd times 3 minus 5 times 3. So, again, this is a great one for Desmos. You don't need to put it in Desmos, but it's helpful to do that. If we did our order of operations, we would tackle what's in those parentheses first. So within the parentheses, I'm looking right here. I would probably start with that 5 times 2. What's 5 times 2? 10. Yes. Perfect. And then I have 2 times 3. What is that? 6. And then I have 10 minus 6. That gives me 4. Good job. 4 and then to the 3rd power. And then on the bottom, here I would have to take that 2 to the 3rd power. 2 to the 3rd power is the same as 2 times 2 times 2. What's 2 times 2 times 2? That's 8, right. You'd think it's 6, right? Everybody, you would think so. 2, 4, 6. You're right, but it's 8. It's actually 8. So then we go 8 times 3. So this is my 8 times 3, 24. And then 5 times 3. What is that? Yeah, and then 24 minus 15. What is that? 9. Good work. Perfect. So we have 4 to the 3rd over 9. And you could even put something like this into Desmos. You know, you could do that. Or you could kind of type it all in how it is. So what is 4 to the 3rd? Oh, someone put 64. Very good. That's right. That is what you get. Now, typing it into Desmos, it would look like this. Oh, I tell you. Yes, I love you, my buddy. Okay, so we're gonna go into Desmos and we'll type it in. Now we're gonna have to put it in as a, that is my Logan, sure is. He's being picked on by the big bad 5-year-old, right?
Oh, we can look crossbow. Why you save me?
Okay, so we're kind of typing it in exactly like how it is in Desmos there, because I want to show you something. And then when we raise it to the third power, oh, why are you sad? Oh, I'm all worried. That's funny. That's okay. There's always more ramen. Okay, I wanted to show you guys there. Look at how I have that typed into Desmos. Now you might see that you're getting this crazy decimal. You guys can click on this little circle next to the decimal to have it converted into a fraction.
Someone's in trouble.
Oh, those children, I tell you. I should. I don't even know what they're mad about, but they're like full on yelling at each other. So Desmos can convert into a fraction. Okay. Cool. All right, so now we're getting into regular order of operations. You took my diaper, no. Now we're getting into regular order of operations, okay? What do you guys think this one would be? Take a minute and evaluate it. What do you guys think we would get? Remember, you got to follow the order of operations.
5 plus 4.
Yep, we would do that first,
Minus
definitely.
3, and then minus 3 times 8.
Yep. So what do you guys think? I want you to try and evaluate the whole thing there. Let's see what you think you get. People are saying negative 15. You guys agree?
Yep.
All right. So let's see. I'm sure you're right. So 5 plus 4 is 9. And then we definitely do that 3 times 8 first. So we do the parentheses, then the multiplication,
She left.
and then we do the subtraction. Very good. Perfect. Negative 15. Again, if you type this into Desmos exactly like that, you will get the answer. What does this part mean, guys? Right here.
It means it's supposed to be like times itself.
Right.
That it's supposed to be like it's supposed to be right there, but I guess they couldn't do that.
Yes, you're right. To the power times itself, how you guys are all putting it, that's perfect. Very good. So if you ever see that little caret, it's just talking like this. Well, it's because we're not really going 2 times 2. We want to take whatever 14 minus 6 is and multiply it by itself.
Yeah.
That's what they're trying to say. So I just want you guys to know that that little caret symbol means that same thing. Oh no, I'm glad that you asked. I really am. Keep it up. Yep, 3 squared is 3 times 3. You're right. Okay, so what would we do next here? What would come next? The 3 plus 5. Yep, 3 plus 5 is 8. So that's there. I definitely got to do the squared, but I got to do the 14 minus 6 first to figure out what I'm squaring. What is 14 minus 6, guys?
8.
8. Very good. So we have 8 squared plus 8. Now what do I do?
Now you do the square.
We got to do the square first. 8 squared is the same as 8 times 8, which is, it sounded like I said H, but I did not. I said 8. What's 8 times 8?
64.
64. Very good. Plus 8. You definitely do get 72. Nice job. Could you just type this into Desmos just like that? You sure could.
Except you don't
Could.
have to put the caret thing.
Right. They let you do the squared thing. That's true. That's a good point. You don't need that caret. Good stuff. Okay, look at this one. Whenever you see, carrots are gross. I totally agree. Whenever you see like a little radical symbol or the square root symbol, that's just like saying parentheses. So go ahead, guys, evaluate that or type it into Desmos and we'll all compare answers. Once you have an answer, go ahead and write it on the screen. There's even a Desmos app for your phone. It's pretty cool. It looks like this. It's a really neat app there. So a lot of people are saying 21. Looks like someone thought 2. And I got, when I typed it in, I got 21. 21.
I thought you were just talking about that one part.
Oh, about this part?
Yeah.
Yeah, that would be 2 because 8 minus 4 is 4, and then the square root of 4 is 2. So you have 2 plus 28 minus 9. And guys, whenever you have addition and subtraction in one line, we always go left to right. Sometimes you might get confused and think you have to do one part first and then the other, but no, you always just go left to right. I like this. It looks like a sun. Looks like it's going, 21 is the answer. Okay, what about this one? Go ahead and do this one, guys, and then tell me what you think. Oh my gosh, it did look like an atom. You're totally right. Okay, what did you guys get for this one?
I got 2.
I did as well. Very good. Someone looks like they got 29 over 14. I think that's just a subtraction error because 6 squared is 36, and 36 minus 8 gives you 28.
Yeah, and the one thing I liked about it is that when I actually was doing the division part, it automatically put into a fraction.
Yeah, yeah. When you hit divide, it puts it as a fraction. That's really cool. It helps to see it. I love the atom. Very good. Yes, definitely 2 for this one. We would take it kind of piece by piece. You have to simplify the top and the bottom before you can do the division. That's the big thing. So we would do the 6 squared minus 8, which is 28. And then we would do the 3 squared is 9. 9 plus 5 is 14. And then you would divide, and it gives you 2. Good. Good stuff, friends. All right, let's have you guys try this one. And I don't like having numbers there. It looks really confusing. Thank you. All right, what do you guys think for this one? Is it 5, 7, or 14? There's nothing behind the block. Don't look behind the block. Looks like we're thinking 7. Exactly. What happens when you have this minus minus next to each other? What does the double minus turn into?
Like you could turn it into a positive.
Positive. You're right. Very good. So this is the same as 20 plus 8 and 2 plus 2. Good. Good stuff, guys. Good work. All right. So now we're going to grab those foldables. Okay, those things that we prepared in advisement that you were like, why is she having us do this? Let's go ahead and grab those because we're going to take notes on some properties. And all that you have to do, all we're going to do, on the back of the tab, we're going to write the rule. And on the piece of the paper that you did not cut, you're going to write the example. And I'll tell you what we're going to use. So the first property that we're going to talk about today is the multiplicative identity property. And all that says is that when you multiply any number by 1, you get the same number again. That's all. So the rule that you guys are going to write down is right here. Oops, dang it, I did it again. Jen, come on, is right here. A stands for a number. You're going to take any number times 1 is the same as 1 times that number, and you get the number again. And I always think that sounds confusing. That's the official rule, and that goes on the back tab of your foldable. The rule does. And the example that you're going to write down, because examples are how we really make sense of things, is you're going to say, if we took 3 times 1, well, 3 times 1 is exactly the same as going 1 times 3, right? 3 times 1 is 3, and 1 times 3 is 3. So either way, you get 3. So the multiplicative identity tells us no matter what, when you multiply any number by 1, you get that number back again. Does that make sense, guys? Does it make sense where we're writing them? And if you end up switching the two, it does not matter. It's your foldable. You make it for you. Okay, and when you're done with this one, go ahead and write yup. So I know you're done. Aiden's done. Cece's done. Callie, are we done? And Ben? What about the rest of you guys? Alyssa's done. Isabel's done. What about Grace, Cassandra, Annabelle, Ayub? Annabelle's done. What about Grace, Cassandra? Oh, Grace is there. Cassandra or Ayub, how are you guys doing? Questions on where you're supposed to write that stuff? I love your emojis there. Cassandra or Ayub, how we doing? Or Anthony, where's your... Aha! This one. Ayub is done. Anthony or Cassandra, how are you guys doing? No, I can't right now. What do you think, Anthony or Cassandra? You guys still with me? Oh, there's Anthony. Okay, I'll have to check in with... Oh, Cassandra, you did. Okay. Thank you, thank you. Oh. Okay. Cool. All right. Next property. Next one we're going to do is the commutative property of addition and multiplication. Basically, that just tells us you can add or multiply in any order. That's it. So the rule that you're going to write down, we'll talk emojis after we're done, guys. Totally good. The rule that you're going to write down are the letters here. A plus B is the same as B plus A. So I believe on your foldable, the commutative of addition is first. So this is tab 2, and this is tab 3. And then the example is this 3 plus 5 is the same as 5 plus 3. You can add in any order. And the commutative of multiplication tells us you can multiply in any order. So that's what you're writing down for tabs 2 and 3. Good stuff. Now there's 2 properties that we're doing. Okay, thank you. So if you're done, go ahead and let me know that you're done. So Alyssa, oh wow. Oh my gosh, too fast. Alyssa, you guys are too fast for me. I love it. Okay, Alyssa, Ayub, Callie. Grace, Cece, Ben. Eden, Annabelle, Isabel. All right, Anthony, when you're done, let me know, my friend, and I will move us along. All right. Perfection. Okay, now we've got the distributive property. This is tab 4. So what you're going to write for the rule here, we'll write the rule right on the screen. I like to move my chat over here. Oh my gosh, stop it. Silly chat. Okay, so the rule that you're going to have, if you have A times B plus C, so a number times 2 other numbers in parentheses, you can share that number by multiplying. So you would say it equals A times B plus, oh, and I want to write it so it's not all jumbled there. So that equals A times B plus A times C. That's your rule. And then your example of the distributive property is right here. If you take 5 times x plus 6, we can distribute that 5 by multiplying it. So we get 5 times x plus 5 times 6. And then when you simplify it, you get 5x plus 30. Right? CC, he's showing off his emoji muscles. He surely is. So we've got our rule and our example there. I think of it like that 5 is like a guy who has candy. And he's sharing the candy with everyone.
Okay,
5
okay,
times
good.
x,
That's where it went. Okay,
5
good.
times 6.
I thought it was going somewhere else, but
Nope, I wouldn't take it there, I promise. Look
Hey,
at
guys.
I grew another head. Ah, I'm just kidding. It's my big guy.
Go now.
Don't trust the 5.
Go for 5 now.
That's right. He's got candy. Don't trust him.
Please.
I like that. He says he's got candy, but don't trust him. He's got a creepy white van. Aw, you're so sweet.
Hey, wait,
No, you don't tempt kids nowadays with candy. You test. You can trick them with free Wi-Fi.
Right?
Yeah, I was gonna say.
Right. Logan, they're saying hi to you. Say hi. Say hi.
Hola. Hola, amigos.
Harley, oh my God, you're so fat.
Can I help him?
Nope. Leave
Why
him
do you
be.
have to sit on my lap?
Because she loves you.
I know, but she's annoying sometimes.
I get it. I've got my cat annoying me, right? He's a big kitty.
When she gets her Halloween costume, I'm gonna take some pictures for her Instagram.
Oh my gosh, please do. Do you have Instagram or does she have an Instagram?
We both do.
Oh my gosh, that's awesome.
It's Harley the tortoiseshell.
That's awesome. Okay, Logan, let me finish. I'm almost done.
Self promo. Follow her on Instagram.
Oh my gosh, that's awesome. My Logan has autism as his superpower, and he likes to lean against me because he likes the way that feels. Gives him some compressions. So, if you ever see me all of a sudden going like this, means I'm helping my friend Logan. My son, my boy.
This is my only child.
Yeah, animals are children.
Yeah, that's what my sister
I
always
protect
says.
her with all my life.
Everybody has superpowers.
Okay. Alright, we'll play. I'm gonna bring out my favorite.
I have Pokemon superpowers. I'm obsessed with playing that game, Pokemon Go. Yes. Aww.
This is our 9-year-old Chihuahua.
Oh, so cute.
We're thinking about getting another one, and it's gonna be my puppy. I'm trying to convince my mom to let us get another Chihuahua.
I love that. Hey, what are you doing? Stop
Say
that.
hi.
Okay.
What? Stop
Say
fighting.
hi. What up?
Can I show you how you do math?
Go sit down. Okay. I guess. Oh my gosh, 5 months. That's awesome. Nice. All right, I'm going to skip to the next slide. I'm assuming we all have the distributive property done.
That eats cat.
Oh, that's awesome. Kamapoo. That's cute.
I can't believe I'm saying this, but can we get back on track on math?
Oh, yeah. I can't believe I'm saying this. I like that. Yes, we can.
Oh, hi.
Guys, are we all done with the distributive property?
Yeah.
Okay. I think I'm going to say we are. All right. We're almost done. So then we have the multiplicative inverse property here. The rule is down below. Logan, I'm almost done. Go sit down. Go sit. The rule is right here. It says example, but that's the rule. Okay, when you take a number, and if you multiply by its reciprocal, or the fraction, the flip of it, you will get 1. Okay, so that's our rule. Our example that goes on that non-cut page is if we take the number 7, and let's say we wanted to find the reciprocal of the 7. The reciprocal, if we flip it, is 1/7. Logan, stop. then you would end up with 1 again. So anytime you take a number and multiply by its reciprocal, it'll give you 1. And a reciprocal, remember, if you take 7, if we wanted to turn that into a fraction, it'd be 7 over 1. So when we say reciprocal, we flip it. So we get 1 over 7. So this is the rule you're writing down on the back tab, and this is the example you're writing down on the other page. Cool. So Alyssa's done. Isabel's done.
Done.
Annabelle's done.
Okay, you gotta stop being a bird. Okay.
Ben is done. Grace is done. Cece's done. Aiden's done. Callie's done. Ayub is done. My friend Anthony, how we doing? All right, I'm going to switch to the next slide. Remember, if you guys need me to go back, I can once we're done. Oh, thank you. Thank you, Anthony. Okay, moving on down the list. We only have 2 more slides left. We're doing awesome. This is the additive inverse property. This one says if you add a number with its opposite, you get 0. That's it. So this is our rule. And this is our example. So the additive inverse says if you add a number with its opposite, you'll get 0. And a lot of this stuff is stuff that we already know. We're just kind of putting an official rule with it. So a number plus its opposite. So for the homework, you guys will just have to identify it.
Done.
Done. Awesome.
Done.
Annabelle's done.
Done.
Aiden is done. Cece's done.
Done.
Who else is? Oh, Ayub, is that you?
Yes.
Awesome.
Now I can put that on my bucket list now.
What is that?
That I told my teacher and the classmates to continue with the math class.
There you go. You helped refocus. There you go. It's good stuff. Grace is done.
I'm the teacher now.
Hey, you'd be a good teacher. Oh. I can't. Your camera's not on. Anthony's done. You guys are gunning for my job. What? I'm just kidding.
Nah, I don't really want that job.
I have an epic job. I love my job. Best job in the world. I'm serious. Oh my gosh. Child, what are you doing? Stop that. Okay, so this is our last slide. This is the associative property. And this tells us when you have 3 numbers or more, you can add or multiply them in any order and get the same answer. So our rule is right here. And this is our example. And then we have our rule, and then our example. That's it. So associative of addition is the second to last tab, and then associative of multiplication is the last tab. And that just tells us you can add in any order or multiply in any order. Oh, this child, I tell you. All right. And with that, this is our last slide. So if you are done, you are free to go. Thank you for putting up with my crazy children being